Good morning, Tehmina Khan is here in TKMaths 1. In today's video, I will explain to you the concept of equation of a circle, which is a new change in the A-level mathematics P1 syllabus. It has been added under the topic coordinate geometry. So before I begin, you can see on the top my blog address where my free YouTube videos are available. TKmathsisfun.blogspot.com. And I would like to announce that I have launched my website TKmaths.com. You can visit that site. You may find it useful. I am offering online classes, also topical classes and course-wise classes as well. So let's begin with the requirement of the CAIE syllabus first. So according to CAIE syllabus, we need to understand the equation x minus a whole square plus y minus b whole square equals to r square. What does it mean? It means your center of the circle is at a comma b and your radius is r. We will see the example and we will understand it better. Then it is saying the algebraic method to solve problem involving line and circles. So it means what problem will be given to you, in which few information will be given to you, and you will have to find the equation of the circle. And this includes that if equation of a circle is given in this form, x square plus y square plus 2gx, so basically you will have one number here, right? Plus 2fy plus c. So again in the equation you will have some number or something unknown which you will have to find out, plus c. So use the elementary geometric properties. We will see that also in the example. And then, for example, tangent perpendicular to radius, angle in a semicircle. So all these properties of circle we will use to solve equations or to answer the questions in which equation of a circle has to be given in this form, or it is given in this form and something is asked. Okay, so let's see. The equation of a circle is given x square plus y square equals to r square. It means that center of the circle is at origin and your radius is r, right? Number 1 point. Number 2 point, which we have already just discussed, if it is given in this form, x minus a square plus y minus b square equals to r square, then a and b are your center of the circle and r is the radius. You can note down these points in your copy because we will see the example soon. You can put the video on pause and note it down. And if you're revising, then it's fine, it's a recap. Or if equation of a circle is given in this form, x square plus y square plus 2gx plus 2fy plus c, then your center will be minus g and minus f. And your radius will be root f square plus g square minus c. And we will see the application in the example. So let's see the first example. Find the equation of the circle which has a center 9, 1 and radius r, which is 4. So it is very simple. Center is given to you, radius is given to you. So simply in this form, I will substitute in place of a 9 and in place of b 1. And my r will be 4 square. And I can leave this equation in this form. Second question. Determine the center and radius of each of these circles. Now this is given in this form. X square plus y square minus x minus 10y plus 5. So we will compare it with the general equation, which is what? Which is x square plus y square plus 2gx plus 2fy plus c. So we'll compare our equation with the general form and try to get f and g out of it, because then center of the circle will be minus g minus f. Do not get confused. G will come first, f will come first. Whatever is the coefficient here with x, that will be your x coordinate of the center of the circle. And with the y power 1, whatever the coordinate is here, that will become your y coordinate of the center of the circle, right? So let's compare. In the question given to me, minus 1 is my coefficient. And here it is 2g. So I can say 2g equals to minus 1. So g equals to minus half. So in the center of the circle, g is your x coordinate because it was written with x. So minus g is your x coordinate of the center of the circle. So you will plug in minus half here. It will become plus half. Similarly, I will compare minus 10 with 2f. So when I'm comparing 2f with minus 10, I got f minus 5. So in the center of the circle, which is in general minus f, I will plug in the value of f here. It will become plus 5. So my center of the circle will be half comma 5. Now, question is saying find out the radius. Now, what was the journal form? You remember? F square plus g square minus c. So my f or g mean the x coefficient of x, and this. In this case, it is g square plus f square minus c. So I'm writing half square plus 5 square. Now if I compare with this, my c is 5, right? If I compare question with the general form, c is 5. And in the formula, it was minus c. So I have written here for quick recall. So I'm substituting the value of g and f, and minus c, I have just shown you c is 5 here. So I'm writing the value of c, and I calculated, so my radius is 4.5. Now let's see the second equation. 2x square plus 2y square minus 8x plus 2y plus 2. Now in the general form, I should have here the coefficient 1, x square plus y square. So what I will do, I will divide this whole equation by 2. Agreed? I will divide this whole equation by 2. So this will be my new form of the equation. Now I will compare it with the general form, which is x square plus y square plus 2gx plus 2fy plus c. So exactly in the same way, minus 4 equals to 2g. I will get the value of g minus 2. Then coefficient of y is 1. And in the general form, it is 2f. I'll compare with that. And my f will be half. And then I will find out the center of the circle, which is actually whatever the coefficient of x here, the unknown. So minus g minus f is my center of the circle. I'm plugging in the value of g and plugging in the value of f. So 2 comma minus half is my center of the circle, because minus 2 multiplied by minus will become plus 2. And half multiplied by minus will become minus half. Now radius of the circle, if you see in the equation, your c is 1, right? And we already have g and f. So I'm plugging in g square plus f square minus c, and c is 1. So I'm getting the radius of the circle root 30. Now let's see the third example. It has two parts. The first part is the same which we have just done. So equation of a circle is given to you in this form, and you have to find the center and radius of the circle, right? So do you remember what we will do? We will compare it with the general form, which is x square plus y square plus 2gx plus 2fy plus c. Okay, so first of all, comparison we will do. And when we will do comparison, my center will be minus g minus f. Like I said earlier, if somebody writes here 2fx plus 2gy, then his f will be the x coordinate of the center of the circle. And his g, because that person is writing 2gy, then g will be the y coordinate of the center of the circle. So do not learn it by letter, rather remember it by, because in the original equation, you will have a number here, right? So whatever is the coefficient of x, that thing will go here. And my radius is f square plus g square minus c. And here you are squaring and adding. So which one you write first doesn't matter. Anyway, so let's just start. So I am comparing this with 2g and comparing minus 4 with 2f. So I got my values of g and f. So g is 3 and f is minus 2. I hope no confusion here. It is very much like what we have just done. So then I'm plugging in minus g minus f, my center of the circle. So it will be minus 3 comma 2. Because 3 will go here. 3 multiplied by minus is minus 3. Minus 2 multiplied by minus will become plus. So my center of the circle is minus 3 comma 2. And then I'm plugging in the values. So my radius is root 17. So you can put the video on pause and you can check yourself. So this is how you will get your radius. Let's see the second part of the question. By the way, C I got from the comparison here. In the question it was given minus 4 and in the original equation it is plus C. So that's why my C is minus 4. So when I plugged it in the formula, I got plus 4, right? So let's see the second part of the question. Okay, so the second part of this question is saying, find the coordinates of the point where the circle meets the line with the equation this. So equation of a circle was already given to you in the question. And they are saying, find out the points where this line y is equals to 3x plus 4 meets the equation of the circle. Now if you visualize it, it may mean that line is touching the circle at one point, meeting at one point, or it is meeting at 2 points. There was the third possibility that they are not meeting. It means line will be somewhere else. But question is saying find the coordinates of the point where the circle meets. It means they are meeting somewhere. So we don't have to show that either it is meeting or not. So that's why I'm visualizing only these two cases. If we will get two answers at the end, it means it is meeting at 2 points. So what do you understand? When we say meeting, it means they are intersecting. And when we have to find the point of intersection, we always solve two equations simultaneously. So I will solve line equation and circle equation simultaneously. So I will substitute the value of y, which is 3x plus 4, here in the equation of the circle and here in the equation of the circle. You can see I have substituted the value here, right? And after that I will simply solve it and get the values of x. If I get two values or one value depends, I will plug it back here or here, wherever you want, because they are meeting, so you can substitute it anywhere and get the value of y. So let's solve it. Now what comes here in your mind? Algebraic identity a plus b whole square, which is a square plus 2ab plus b square. So using that algebraic identity, I will expand it, right? So I'm repeating what I have just said. A plus b whole square. So I will apply algebraic identity, which is a square plus 2ab plus b square. So using that identity, I have expanded. It will become 9x square plus 24x plus 16, right? And then I am expanding the simple substitute multiplication. So then I get this quadratic equation. Because I can simplify it, I divided the whole equation by 2. I like to simplify the equation first before solving it. After that, I am applying factorization method, which usually students say middle term breakup, right? So like this, you will make factors and you will get the values of x. It means line is meeting at 2 points on the circle. So now these values of x you will plug in. I have plugged in here in the line equation to get the y coordinate. You can see here. So you can try yourself, substitute it, and my coordinates of meeting points are coming -2, and 1 upon 5, 23 upon 5, right? So I hope this is clear. Okay, whenever you have to find the meeting point, you solve them simultaneously. So let me solve one more question as an example. Now this is the last example of this video, and few parts of this question are difficult for or challenging for students. This question has 4 parts, right? So let's see the first part first. We will solve it and then we will go to the next part. Now the question is saying a circle has center -2, 4 and radius 5. Find the equation of the circle in this form. Right? I'm repeating. This is the center of the circle, which is -2, 4, and radius is 5. You have to write it in this form. So let's see how we will solve it. Now what we know, that if equation of the circle is given in this form, then -g minus f is your center of the circle, and your radius is f square plus g square minus c. So do not get confused, you can write g first, f second, doesn't matter, both are square and both are adding. Okay, so do not get confused why I'm writing f first. Anyway, so now the important thing to note here is that the coefficient of x, which is unknown in this case, is g. So I'm writing this as a x coordinate of the circle. So coming back to here, the equation of a circle has center -2, 4. So if I compare it with the center of the circle of this form, so I can say minus g equals to -2. So g is equals to 2. Making sense? Minus f I will compare with 4 because I need to get g and f. So it will become f is equals to -4. So I got the value of g and 4, which I can plug in here. Is it right? Now I will get C, because I need to plug in c here. So in the question, radius is given to me 5. So I will plug in 5 here. In place of f, I will plug in minus 4 square and 2 square, and then I will solve it. Right? Let's see. Okay, so don't get confused here. Let me write here plus so that you are not confused. Rather, you will understand that when the power is even, the term becomes plus automatically. Do you know this thing? I'm sure you know. So I'm simply substituting the value of f and g here, and c was -5. After solving this, because r is 5, f is -4 from here, g is 2, c is unknown, which we have to find out. So when I solved it, I got c equals to -4. So now I will plug in the value of g, f and c in the general equation and get the equation of the circle in the form which is asked. So question was asking to bring the equation of a circle in this form, and we have found the value of g, f and c, and I'm plugging in this general form. You can see I substituted the value of g, I substituted the value of f, I substituted the value of c, and then I got the equation of a circle in the required form. So part 1 is done. So my a is 4, my b is -2, and my c is -4. What is the second part of the question asking? Show that the tangent of the circle at the point -5, 8 has equation this. So can you visualize what does it mean? Let me help you visualizing it. Suppose this is the circle and the center is, what is the center we have just found? -2, 4, right? So we have to show that the circle at this point has this equation of the tangent. So the point P, let me write it here, P. Okay. So the point P is on the circle and the tangent you draw there has the equation, this one. You have to prove this point. So this is the question. I hope you can visualize it now. So now we know that tangent and radius makes perpendicular, right? So to find the equation of the tangent, which is a straight line, what do I need? I need a gradient and I need a point. Point I already have. So I need a gradient. Then using the coordinate geometry concept, I can easily find the equation of the line. Okay. So because radius and tangent are perpendicular, if I can find out this gradient, I will simply take inverse of that gradient and multiply by minus and I will get this thing, gradient of this line. Do you remember that concept? So let's find out the gradient from the center of the circle to the tangent using the formula y2 minus y1 over x2 minus x1, because this is a straight line, so I can apply this formula. So the gradient of this line is 4 upon minus 3. You can see here I have subtracted the two y coordinates and x coordinate. Points are given here, minus 2, 4 and minus 5, 8. Now for the equation of the tangent, y is equals to mx plus c. I have to find or prove the equation of this tangent, right? So the point is minus 5 and 8. I am plugging in here. And because this tangent is perpendicular to the radius, so the gradient I found, I am taking inverse of it and multiplying by negative. So it will become 3 over 4. And I got the value of c. Simply plugging in this equation of this line, value of m and c, and then rearranging. So I have proven here the line of the tangent, which is 4y minus 3x minus 47 equals to 0. And this is what you had to prove. Let's see the other two parts of the question. The next part is saying verify that the point T, which is 3, 14, lies on the tangent. So do you remember what you do in this case? Because this is a simple concept. I hope you can recall. Whenever you have to verify that the point is lying on any line, because tangent is like a line here, so you'll plug in these points in the equation. So let's see here. So point was 3, 14. So in place of x, I will write 3. In place of y, I will write 14 and I will solve it. So if I get same answer what is here and here, then it means it is verified that the point is on the line. In this case, it is on the tangent. Now this last part, some of you may not know. Find the area of the tangent CPD, and I will use determinant method to find the area of the portion or area of the region which is covered by these 3 points, CPT. Okay, so I don't need to draw here. The only thing is that the area is covered by the point CPT. So let me show you or help you visualizing it also. Okay, so here is the visualization, because question is saying find the area of the tangent CPT. Basically it is area of the point CPD, right? The area which is covered by the point CPD. Now we know C is the center of the circle. P is the point of the tangent where it is meeting with circle. And T is another point on the tangent. So if you visualize, it is making a right angle triangle. Because I told you tangent and radius are perpendicular. So we can apply the formula half into base into height. We already know this height. It is a radius of a circle. It's 5. So only thing is we have to find the distance PT. And we know the formula, which is distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. So I have point P and T. I'm simply substituting here. And I got the distance PT, which is coming 10. So just showing it to you so you can see what I'm doing. This is the x coordinate and this is the x coordinate. So minus 5 minus 3 whole square, right? Plugging in here. Then 8 minus 14, plugging in here. So when you will solve, you will get 100, which is root 100 is 10. So now I'm substituting in the formula area of a right angle triangle, half into height into base, and I got 25 square unit. Now why I want to introduce matrix method, because many of the students are unaware of it and it is very useful. In this case, the situation was very clear. If you have any polygon, the region which is covered by many points, you can use this determinant or matrix method. Now see how do we do it. If you're not interested to learn, you can switch off the video and fine. Otherwise, you can continue watching. So the point which are covering this region, in this case it is right angle triangle, are CPT. You can start writing, the area formula is half. Now this is modulus, determinant modulus method, right? What I'm doing, I'm writing this point, first point here, minus 2, 4. Then second point, minus 5, 8. Third point, 3, 14. And the first point we repeat here. Now in case if I want to start from here, because one can think which point will come first. So I can start with this, 3, 14, minus 5, 8, minus 2, 4. And the first one I will repeat here. So whatever you want to write here first out of all these, you can. But whatever you write first here, you have to repeat here. Now what I'm doing after that. See here. I'm multiplying this by this, which is 16. Plus multiplying this by this, which is minus 70. Plus multiply this by this, 12. So like this, diagonally, you multiply and add. So I have multiplied and added, multiplied and added. Now we will go like this. We will multiply and subtract now. So if you see here, minus 2 times 14 is minus 28. And I am subtracting. Then 8 times 3 is 24. I am subtracting. Then minus 5 multiplied by 4 is minus 20. I am subtracting. So I am repeating. After writing points in this form, like this you multiply and add. You can see here. And like this you multiply and subtract. And then when you will solve this, either your number comes in plus or minus, you ignore the sign, just pick up the numeral value. That is the purpose of the modulus. And divided by 2. So my area is coming 25. So you can do this investigation with other points and try it out. So thank you very much for watching this video. If you have learned something, then press subscribe and add, and do visit my website, which is TKMaths.com. So let's see, in the next video I will make the new change, the other change in the syllabus, which is about transformation of the graph. So let's see then. Allah Hafiz, take care.